I'm going to continue with a general introduction about why we communicate science. Well, hopefully you sort of have an idea why I want to do that, because you're sitting here, you applied for this. But let me give you more reasons to make you guys firm believers into science communication, and that you're really at a good place here, and this is something that's really worth investing, learning about. So why do we communicate science? And when people ask me that, this is the story I always give them, because it's a true story, it's my story. And it relates to this, my trauma from this solar eclipse in '99. So I was a student, second or third year student of astrophysics. And so that was the same summer, the same year, after bombing. People were freaked out a bit, but still, it's a solar eclipse. It's fun. But people get scared, right? So the government basically, they called our professors to ask them, oh, can you come to the government and explain to us about this solar eclipse, and she would be scared and so on. So one of my professors went there and talked to them, well, listen guys, okay, this is just a standard celestial event. It's been happening as long as the Earth exists, and there's nothing to worry about. But they started asking questions about really pseudoscience, and they weren't convinced. So eventually, official government standpoint for that eclipse was, it's better to be safe than sorry, and safe means locking people inside during the eclipse, because who knows what's going to happen during the eclipse. And some of the effects, bizarre effects, so this was official, it was in the news, in the primetime news, it was in the newspapers, and I always show this because it's funny, but it's bizarre. So some of the medical consequences from the eclipse are fast heart rate, gastric problems, itching, a high blood pressure, high sugar level in the blood, and my most favorite, frequent urination. Don't know how, but actually that was, and imagine reading this and people got scared and not knowing about science, and they locked themselves inside. And we didn't have anything organized, but we went to a few of our students, we wanted to, because this is once in a lifetime event to see it at your location. There's my, but this is how it looks. So we were observing it, but this is how it looks in towns. So this is from the city of Fujice.
Real footage.
It's like apocalypse. It's like Walking Dead without the dead. Standstill, complete standstill of life. And it was the same images. My dad called me, and it was the same thing in Iceland, it was the same thing in Belgrade. It was like, in the afternoon, the traffic should be like crazy, but
not at 80.
Same thing.
I recall the experience, so we didn't have some measure, so we were watching it.
Yeah, look at this.
I didn't even know that it happened in Serbia that you had these kinds of measures.
Oh yeah, this was crazy. Who thinks this is crazy? Right? Okay. But most of the people didn't think that's crazy. Most of the people were scared. And we were in the brink of a new millennium, right? New century, 21st century. And we were hidden in our homes like cavemen, afraid of fire and, comets and gods above and so on. So that left a really big effect on me. And so I urge you to look at this video. It's fun, but depressing. Anyway, so that is what actually made first to think about, oh my God, people don't know science. People are scientifically illiterate. And it's up to us scientists to teach them about science, to make our society scientifically literate. And this solar eclipse thing showed me how bad things are, right? How desperately we need people who communicate science well. So that's my story. That's why I'm into this. Now things have gotten better. I mean, we had a few years back a partial solar eclipse visible from Serbia, probably from Bosnia as well. And I've seen people on the streets watching the eclipse, so that's fine. It's better. But now we have, it's 21st century. People don't believe that Earth is round. People don't believe that vaccines save lives. I mean, coronavirus is spread through 5G antenna built in your mask. I mean, it's not the issue of solar eclipse, but we still have a lot of issues, right? So that's why we need to learn about science communication. Okay, so let's first define what is science communication. When we say science communication, what do we think by that? So if we ask Wikipedia, you're going to say, oh, it's which is basically talking about science topics to non-experts, right? And but what I consider science communication is something more broader. I don't include just non-experts. What I mean when I say science communication, I mean talking about science topics to anyone. So they're different. So sure, most of the time we talk to non-experts, but there is also a difference in how you talk about science to experts. There's a difference of how they're going to receive your idea. So those are all different forms of science communication. So I'm gonna stick to my definition. This is how do we improve a way we talk about science to anyone, depending on the occasion. And it matters. I mean, how you do that, it matters. I mean, you all know, all of us have that one friend who is the average joke, who can tell a joke, but basically sucks, And so it matters. It's not just about the content, what you tell. It's how you tell that story, how you tell the joke and everything. I mean, have you seen TED Talks?
Yes.
Right? So people love TED Talks. And it's good ideas and so on. The best thing about TED Talks is the story. It's how they get you. It's not just, they talk about this cool idea. No, I mean, those talks are good, on the emotional human level. It's a good talk, right? You enjoy listening to that talk. It's like watching a good movie or reading a good book. And and they realize that. So basically, when you organize a TED event or a TEDx event and so on, they have trainers. They have trainers who train the guys who want to. So they invite someone to give a talk because they have something interesting to tell, have some interesting science, but to make sure that the audience receives it really, really well and gets the idea, they have trainers who then work with those people how to tell that story in such a way so that people will get it and remember it. Okay? So it's important how you tell the story. It's important how you talk about science. Because if you communicate your science and any idea well, it's going to get remembered. Okay? It's not just about, I have this brilliant idea. It's about how you explain it to others so that people will get, how good that idea is. I mean, it took people a while to figure out relativity and quantum physics. These are difficult concepts, and it's difficult to talk about it, and there were no good science communicators. Now, who does this? Who communicates science? So when we think about who communicates science, whose job is this to communicate science? So we think, PRs and the science institutions, okay, so media, science journalists, we have educators, teachers, and so on. So we mostly think it's their job to talk about science. And scientists and students, our job as scientists is to do science, and students' job is to learn about science. So we can communicate science, but sort of we think it's their job, mostly, okay? But we can do it. Now, which was fine up to some point, but now we're at this age where there's been, major information revolution, which is good on one hand because everything you want to learn and know about, you can just Google it, you can take a course in Coursera, you can do whatever. I remember in the old age when I was a student, we didn't have books in the library, we didn't have Google, so basically you just have to actually sit there and take notes and read from the notes because you didn't have a book and so on. But now, we go to school, we go to universities and so on, but actually if you want to learn about something, it's right there. It's on the internet, you can learn, and you have all the information available, which is fun, which is awesome. But there are problems with that. And it's a problem that we've seen well with this corona pandemic as the issue of now infodemics. That there's a lot of information, but there's a lot of crap information, like bad information, not good information, right? And that can cloud your judgment, and those information can basically make it difficult for you to get the good information that you actually need, that's actually useful. So we've seen this explosion of pseudoscience and content related to this corona pandemic with 5G antennas, with whatnot, and because we have also these social networks, they help spread these ideas like wildfire, right? And they're just very difficult to stop them. So, and what it does, it confuses the general public, confuses people, like it contradicts maybe things they learned in school, feeds their fears, maybe it's some new info beyond what was learned in school, so they don't know how to process it and so on. People get confused. So it became clear that the only way to, among all these informations, to find a good nugget of information that you need is to either have some knowledge on the topic already, so that you can sift out through all the crap and get what you actually need, but you need previous knowledge, or that you have very well developed critical thinking, so that you can evaluate information, is this a reliable source? What can it cross-check this with other sources and so on, so that you and immediately start doubting. So either already have knowledge on it, or have very well developed critical thinking. But most people don't have either of the two. So that is when we run into these problems with pseudoscience and so on. And with science communication, we need to solve it. And because of this issue with infodemics and finding these pseudoscience that it's like everywhere, now we need to jump in. Now we need to step up and join this, help these PRs and media and science journalists and so on to communicate science, because it is our job. We need to step up. We need to, there's not even enough of us to communicate good science as much as there is all these other weirdos and self-proclaimed experts who talk about science on their own. The number of them is just increasing much more rapidly than the number of us who are actually communicating science. And that's why I think basically that we need to increase these science communication skills among students of who study and sort of science, to help regain this trust in science that basically society has lost. Society has lost trust in science. Before, in the old times, it was basically given. You go to school, your teacher is the boss, teacher knows best, you sit there, your parents tell you to do what teacher told you, and so on. So at all times, there was the authority of a scientist, of an educator, of a teacher, was the person who has all the information, has all the knowledge. And you get the knowledge from that person, you trust that person, and so on, or you go to the library. Nowadays, I don't need you to tell me that. I have YouTube, I can learn that from YouTube. So now we have that sort of attitude. There's no one person, yeah, sure, there are professors and teachers, but now it's easier for me to check that information on my own, and I trust my own eyes better, so, so people, because of that, has started losing trust in science, because now they're seeing content that contradicts what they've learned in school, what they've learned from mainstream science, and they think they're seeing the real truth with their own eyes. That creates conflict, and they're losing trust in science. And like every time I've talked to, was this from my elementary school a few years ago, a reunion after I don't know how many years since graduation. So I meet his friend, and he's a flat earther. And usually I sort of avoid him or have different approach, but this guy who I knew since childhood. So I gave him a benefit of the doubt and started explaining it to him. And every time he was conflicted with information that opposes what he thinks is flat earth, his answer to me was, "You're in on it with NASA." right? And he knows me since we've been this big, you know. So they don't have trust in us, in scientists. They think we'll work for this major institutions who all work with cover up on moon landing, you know, in aliens. Deep state, right? We're all part of it. And it doesn't help that I tell them, guys, we're so bad at keeping secrets. Like, if there were aliens, someone would blab. Like, really, I could not hold it. You know, I would blab so much. And doesn't help, because they've lost trust. So now we have to basically help rebuild that trust of society in science. And for that, we need good science communication. And one way to do that is to sort of stop force-feeding society with facts, science facts, but help them learn the critical thinking, right? Help them evaluate information on their own. So a way to do that through science and communication, to make an emphasis not on the information, not on the data, but on how we collect the data, on the scientific method, how the information was collected, how we got to that conclusion. That is what our focus should be. That is how we rebuild trust in science, by focusing not on information, but how we got to that conclusion, those information, learning people critical thinking and scientific method. And talking about current news, talking about science in the news. We see faster than light neutrinos. Oh, we learned in school there's nothing faster than light. Okay, so there's this big elephant in the room. If someone knows that from school and reads this in news and thinks, oh, what's happening here? And a lot of teachers, a lot of professors will go, oh, well, you know, I have so much to cover in my class. I don't have time to talk about this. I have to do this lesson today. But the way to sort of find this science communication, I'm going over time, is to actually address the conflicting scientific information that appears in the news every day as they appear. So don't pretend that it's not there, because people see that information, people make judgment about that information. So it's your job to address the new information every day. But you may wonder, what's in it for you? Why should I bother with this? And I mean, main thing is you learn in the process. And that's such an important truth. I mean, when I was a student, I actually thought, I was like, no, I'm going to be a scientist. I don't want to be a professor. That's sort of boring, repeating the same content every year. There's no growth in that. I want to discover, do science. And then when I started teaching, when I was an assistant, I thought, oh my God, I have to explain this to the students. Crap, I don't know this as much as I thought I knew. So like at a fundamental level, so I was like, oh, okay. So in trying to explain things to myself so that I can explain it to them in really, really simple terms, I really learned science. I learned better science than I ever learned at the university by trying to teach it. And that's such a hard truth. I mean, if you want to learn something, try to teach it. Try to explain it to a kid. Like really, I mean, that's how you learn. If you can put the concepts into these terms and understand what mistakes you're making, what information you're leaving, what, like, then you know the subject. You get satisfaction in the science communication. At least I do a lot of satisfaction from science communication, like people learning about science and basically finding it interesting. And with science communication, you also help change the image of science. Who of you in the room is this? White guy with glasses and a lab coat with a... No one, yeah. And that is the image of science. We think of a white male with glasses and a white lab coat. That's what people think about science and scientists, right? And yeah, look at this room. No one looks like that, you know? So by doing science communication, you're putting yourself out there, and people see, there's a scientist, and that scientist looks like this, and that is not like this. So by doing science communication, you're basically helping changing this image. Okay, and nowadays, if you want to work in science as a researcher and any science-related field, basically science communication and general good communication skills, they become a survival skills, right? It's not just, oh, I do my research in my lab and I'm happy with that. No, who's going to pay for that research? You need to apply for some grants, get some funding. If you want to apply for some grants, you need to be good at explaining what you want to do, why that matters, why politicians should care about. So you need to be good at convincing people to give you money. Comes down to communication. You want to convince people to trust you, that it's not, Bill Gates wants to put microchips in us, it's something else. So you need to convince us. So, and for all that, you need good communication skills. If you want to convince society that science is good, that we should still fund science, that they should allow you to work in your field. So becoming good at science communication will give you tools to do all that. Also, when you do science communication, when you try to explain really difficult topics to people who are non-experts, you are explaining things to yourself and you suddenly become good at explaining difficult concepts. And you'll be surprised how that will work for you in other areas as well. Sort of changing that mind frame and will help you in making your points in discussions about other things. Basically, you'll learn how to, when you have a difficult topic, how to break it down, how to explain it into simple terms. So that's the power of good science communication. And we know, the power of good science communication is evident if I ask you, okay, what are the scientists that you know? World scientists. Give me some names of world scientists that you know, alive or dead. Tell me. When I say scientists, you say who? You think of what? What's on your poster or on your T-shirt?
Always Richard Feynman.
Feynman, okay, who else?
Dan Rosen.
Imaš ispitaš.
Okay?
Albert Einstein.
Albert Einstein, okay?
Maria Curie.
Maria Curie, okay?
Who knows some other woman in science besides Maria Curie? Do you know any woman in science? Any full name?
I mean, who else?
Lisa Meitner.
Lisa Meitner, okay? Who else? Have you, from the TV, who else do we know? All of the live ones.
Great.
Have you watched Cosmos show? Have you watched Cosmos show?
Neil deGrasse.
Neil deGrasse Tyson, who adapted the show from Carl Sagan, right? So, okay. But one thing, so there are some names that repeat a lot, and look at these guys. So, Stephen Hawking, right? So I put just a few, all guys, but okay. And the common theme with these guys is that Feynman and Carl Sagan and Neil deGrasse and Hawking, we know their names, and one of the reasons we know their names is because they're good science communicators, right? I mean, they did science great, but they were great at explaining that science in really simple terms. I mean, I was a kid when I was reading his books, and I was like, oh my God, this is awesome, black holes and so on. So, and he was able to explain things so well that I basically had understood, concepts which I thought were, they didn't look that difficult, but actually were, so that you could make conclusions which you find out at the end of the book, basically, because that's what it means to do good science communication. You can explain so that people can understand and extrapolate and make their own conclusions, get new information on their own from what you taught them. So the power of good science communication is evident here. We are all good scientists, but the good science communicators and others, mostly, there are a lot of them, but they're not as good in science communication. Now, the good thing is this is a skill. Basically, sure, some have a natural talent for it, some less. But it's like driving. Anyone can learn how to drive. So basically, there are some rules, there are some tools. Now it's all available online. You just learn, read, practice, and get better. And that's, but you need to, like in anything else, you need to invest time, you need to keep learning. So that's why we're doing this workshop, because it's important to start young, start with students, and that's why we want to jumpstart you guys with these skills through this Connect meetings that we've been doing. And I should wrap up, but let me give you a few examples. So the main thing about doing science communication is, I mean, there is different ways you can do it, and each way depends, I mean, the way you communicate science depends on what you want to achieve. You want to teach someone, you want to raise awareness, and who's your audience. And for a specific occasion, you choose a specific way. So we're going to be talking to you guys about how to communicate science in a few minutes, in video, and in written. But there are many different ways, so I'm just going to run through some of the examples just to show you all the different ways, and this is just not even everything. So you can do live communications, I mean, in live interactions or interactions through media and through digital networks and so on, but basically use different ways for different audiences and for different goals. So with live interactions like science festivals, science show, live events in schools and so on. And those are activities that are good for inspiring, for short science, to get people to get first experience with science. You can do competitions and some public lectures. Those are all live outreach activities. So that you can do like science festival type events, a lot of big crowds. For instance, what we're going to be learning in this Connect is short, 3-minute science. What you learn here is going to be suitable for applying to this science sort of festival type events, maybe science competitions, and sort of every place where you need to do something in a few minutes. You can give public lectures. That takes a bit more time. Different skills, more seasoned, more experienced audience. You can have discussions there. It's suitable for education. So this is suitable for wow science, first-hand experience. This is suitable to actually learn something in depth. You can do it. I love these informal settings. We've communicated science at Exit Music Festival, where the people come from concerts and drinks, and we give them science on the side. Science on tap. You can do. Sasha has been doing skeptics in the pub, pub quizzes, science pub quizzes, and so on. I love this because you can talk about science and have a beer at the same time, which is awesome. And people then immediately, it's a completely different setting when you're in informal. People are not scared. It's not like, oh, I'm a scientist and you're the audience, but people are like, oh, this person drinking beer, we're drinking beer, we're just chatting, and it's like it's non-threatening even. More difficult terms can fly much more easily when you have a beer than when you're in an auditorium, big auditorium, because it's relaxed, You can communicate science to connecting through the arts. You don't have to learn something new, some new information, but sort of get a visual impression. And we had some exhibits with light and shadows that we worked on, and made some exhibit pieces. All this other connecting art with science. We did city tours, so connecting tourism with city tours of where famous scientists lived and so on. So this is with art students, some exhibit of how art students perceive space. You don't have to communicate exact information, but sort of give people a sort of visual feeling or some other sensory feeling about science. Theater performance, it's just basic science experiments that if you want to put on the stage, add some light effects, add some musics, and voila, you have yourself performance that involves science. We have science on the road, science on wheels with mobile planetariums. Now that you can pack up your lab in a suitcase, get in a car, go to that village, some rural area. They really appreciate it. I love now doing gamification of science, like putting science into games, like quizzes. Well, we made an escape room that basically through which you escape by solving doing experiments, solving science problems, where you can do simulations of forensics or whatever, simulation of doing science in real. Made an Angry Bird piece. Angry Bird is just a shot, physics of shot, and it's a game, but basically it's based on real physics, so you can teach physics to Angry Birds. I love using people as data and community, so that's what we've been doing now. Like using you guys as data, that's a way to communicate science, communicate information, because people then participate. They don't have to do the experiment, but they feel as a data point, right? And they sort of participate. So this is just basics. In the show, we have this HR plot, and it hasn't, it's types of stars and so on, but it goes diagonally, so you can measure people's height through that. It's just you get a sticker, and kids love it, and basically it doesn't matter height, but they feel sort of being part of science. We did a lot of things to change the image of science, making scientists sing. Some people say I did it because I just wanted to sing, but there's some truth to it. We put scientists on billboards, stuff. We made cool shots of scientists doing their hobbies in their environment, making like a movie posters of scientists, sort of things, doing like a pop art, doing famous album covers with our scientists. Again, changing the image of science. So you have a lot of science competitions, like FameLab, Science Slam. Those settings are good also for 3 to 5 minute science. They work like that. They attract a lot of audience. Have you heard about Dance Your PhD? That's awesome. Like people, it's a competition where whatever your PhD is, you make a dance. You don't talk. You don't show. You dance, and people get the answers, and they create this choreographers to explain.
Is that for PhD defense or?
Nah. Actually, yeah, that would be interesting. Yeah. But it's fun. It's fun because you have to think about how do I explain, like, how is lithium made in the early universe with a dance? And how would you do? So that gets you to thinking into different ways of showing your science. People don't have to get it at first, but there's some elements to it. And inviting, which is something that you're going to learn, writing it for the media, for some journal articles, or writing it as blog as Jana does. It's good for the media to have already something prepared to make it easier for journalists. There are some in the West good scientific journalists. Here in our region, not so much. But so basically, it helps if you know how to write it and make it easier for them. If you can create an article and just send it to them. And I love also citizen science and basically telling everyone that they can actually do simple science on their own. There's a bunch of available data, and they can work on real science data. And it's simple as just installing an app on their phone and just doing some basic recognition, but actually feeling that they contribute to actually solving science problems. So those are all different ways. It's actually just a few. There are many different ways, but those are all different ways how you can communicate the science idea to different audiences with different goals. And if you learn how to do that and to adapt to different audiences, to adapt to different settings, then you will really develop this, what has become a real survival tool for us scientists and people in science. And survival tool for the society, because we have so much to the science now that we need to fight, we have to become very good in how we communicate. And basically it's okay for science to be fun and interesting, and that's what you guys are here to learn how to learn how to do that fight. So that's it, I'm stopping.
Okay.
It's an hour.
Thanks.